in information system industry. In order of building any information system, we will need a framework. For what? By using a framework, we can build a system, an effective system in an efficient way. Effective system, that means that is a system meet user requirement or meet quality. Do you remember about the triangle of an information system in the previous class? We have 3 points need to be read when we build an information system. Or we have 2 targets, right? Quality target and productivity target. Remember? Or you don't? So, if we can meet quality target, in other words, we can say that we are developing an effective system, or quality system, or a system for user, for end user. And in the most efficient way possible, that means in a way that we can deliver our information system on time and within budget. So if we make the comparison to the previous triangle, we can see that efficient way here to help us to reach the productivity target. So remember, again, in this course, everything will surround the 3 points: quality, time, and money. That's all. Okay? And we have some attempts to control the developing of an information system in a controlled way. Back to 1960, and we call that is our earlier software development life cycle or traditional system development life cycle or traditional SDLC. So whenever you heard the word SDLC or traditional software development life cycle, remember about the way how people control the building of an information system. So, like 1960, we saw the development of a number of frameworks designed to overcome the problem associated with system development project. What are the problems in 1960s? In 1960, we see some framework to help people overcome problems in developing system project. So what are the problems at that time? Did you do any research about software development in early time? In 1960, remember one thing. People developed any information system by their own. That means based on 100% on the developer. There was nothing to do with the user. Understand the meaning here? That means at that time, during the whole life cycle in building an information system, the developer just make the customer 1 or 2 times. Understand? The developer met the customer the first time to sign up contract and the second time to deliver the system and get the money. That's all. In the middle time, in the developing time, they don't see the customer to discuss about anything. Understand the point here? Yes. So that's why in the previous class we have learned many systems fail because they didn't adapt to user requirement. And we didn't have any methodology or framework to follow to control how we develop an information system. For current time, everybody understands that in order to building an information system, there must be at least 4 phases, right? Analysis phase, design phase, implementation phase, and maintenance phase. But back to 1960, there was only one phase. Actually, there was only one activity in one phase. That's in coding in implementation phase. Actually, in implementation phase, nowadays we have many different activities. But at that time, in 1960, people just coding, and coding. That's all. No analysis, no design, no testing, no user requirement, no management the project, nothing at all. They are the problem in system development in 1960. And from 1960, people think about a way how to control the environment. So that's why some traditional software development life cycle was born at that time. However, the early SDLC have some main criticism, including rigid, no backtracking, or iteration allowed. However, there are many modern development frameworks was built based on the traditional SDLC. We'll have a look at the traditional SDLC like this one. This is the very first SDLC. At that time, people divided the whole software development life cycle into 6 phases. Feasibility, to analyze about the feasibility of that project. Feasibility relates to technical issue. Do we have enough technical skill to implement this system? It's also related to money and time. Do we have enough time and money to implement this system? Analysis. This is the very first attempt trying to understand what user want. But then can put custom on. And then go to the design. In the early phase, the design just including structure design. And there are some activities related to database design was moved to implementation phase. And after implementation, we have testing phase, and after testing, we have maintenance phase. So, have a look at this HDLC. Do you find out any problem with this model? What is this look like? What? Yes, this is a waterfall. What does waterfall mean?
Step by step.
Step by step? Not enough. When you see a waterfall, what is in your mind?
Wow. Waiting.
Waiting? What do you mean by waiting?
Because at the moment there is only task is process.
Yes.
Another
right.
task is waiting.
Yes, that is a waste of time, a waste of resource. Why is that? Because in order to do the analysis phase, people have to complete feasibility phase. And who will do the feasibility activities? Project manager and business analyst. How about other people? What do they do when PM and BA doing feasibility? They have nothing to do. They have to wait until feasibility is complete. And then come to analysis phase. Again, only PM and BA doing the job. Developer, QC, QA, DBA, stay for free, nothing to do. And come to design phase. At this time, again, BA and BA and technical leader will take this role. However, the other people in the team stay for free. Again, nothing to do. They have to wait for a very, very long time to implementation phase. Then, developer have some job to do. And after developer finishing the job, it's the QC turn. You see, this is a very waste of time, waste of resource. What else? With a waterfall, it's easy to get down, right? But is it easy to get up?
Get down.
Yeah, it's easy to get down, but very, very difficult for getting up. Right? What does this mean? This means if in the testing phase there is any problem, any defect that you cannot fix, you have no way to come back to implement the design to analysis. Sometimes you have to throw the project away because you cannot get back. For example, in the testing phase, you find out some defect in analysis phase. What does that mean? You cannot fix it at all. You have to throw away every implementation here. You have to throw away every design here. And you start on over again in analysis phase. This happened one time. However, what will take place when this happens many times? After you fix the analysis, and then again you come back to the testing phase and you find out another defect in design phase. Again, you have to throw implementation away and start over the design again. And in the third time, if you find out some defect related to feasibility, what does this mean? Start from scratch again. So that's why traditional SDLC were criticized. They are rigid, no backtracking, and no iteration allowed. Understand? If you don't understand, please raise your hand. Because the understanding of the traditional SDLCs will be the basic for you to understand all the framework later. Okay. So, after 1960, after the traditional SDLC, people find out there were too much thick phase for implementing an information system, and people developed a new framework or a new methodology that is called SSADM, which stands for Structured System Analysis and Design Method. This SSDM has been built in 1980. That's been 20 years later the traditional SDLC. Actually, you can see that SADM is a brief version of SDLC. You can see here, there was only 5 phases, including feasibility study, the same. Requirement analysis, this is specifying and analyzing user requirement. And requirement specification, this is a phase which is different from traditional SDLC. At this time, people want to spend more time and effort in document the whole system. Before 1980, when a system is complete, it comes without any documentation. No installation guide, no user guide, no help guide, no design documentation, no use case documentation, nothing at all. That is very, very big hole in building an information system. So that's why in SSIDM it focuses on requirement specification. However, this is the documentation focused on user requirements only. And however, please remember, requirement specification is not only one documentation. That is the set of many documentation, including at least use case, user interface specification, vision document, appendix documentation, and in some specific project, some specific industry project, they have glossary documentation. And then the logical system specification. This can be considered like the design documentation related to database design, structural design of the system. So you can say they spend 2 phases for document everything in the whole information system. And then a physical design for the system. And you can see for SSIDM, there was no testing and maintenance. It's finished at the design phase. Or we can say that SSIDM focused in only 3 main activities. The first one is feasibility, the second one is documentation analysis, and the last one is design documentation. That's all. It starts from feasibility and then analysis and then design. No implementation, no testing. It's separate implementation and testing to something else outside of this structure. And what's the difference from SDLC? This looks like waterfall, right? But you have the way to go back. Why is that? Because you have no implementation here, no testing here, just document and analysis. So if you find out any problem in documentation, you can totally come back, track back, and make the modification in the specification, or even from feasibility study. So this can be considered a development in software development methodologies. And for many modern systems nowadays, they're using this structure, SSIDM. Understand? Any question? If you cannot fully understand it and you want me to explain in Vietnamese, just let me know. Because by the end of the day, the purpose of this course is to provide you the knowledge. Understand? Next is a very well-known framework in 1980. We call that IUP, stands for Operational Unified Process. And this framework is the first framework in the IT industry allow iteration. You can see in IUP, it's divided the whole project into 4 main phases. And they call that inception, elaboration, construction, and transition. And you can see in the inception, it can be considered like the initial phase. And in elaboration, it starts having iteration. You can see here, elaboration number 1 and number 2. It depends on the project side. There may be more elaboration. The same for construction and transition as well. That means it divides one phase into many iterations. And in each phase, there are many disciplines or activities need to be done during each different phase. But you can see here, we have business modeling, requirement, analysis, design, implementation, testing, deployment, CCM, BM, and environment. Based on different phases, we will spend different resources and time for different activities. For example, in the inception phase, we spend most of our time and effort on business modeling. And time and effort for business modeling reduced time by time. In elaboration, it's reduced. In construction, reduced again, and nothing complete in transition. However, in transition, we can see that we spend most of our effort and time in CCM and PM. You see here, and less in inception and elaboration. So you can see that IUP is much more complicated than SSADM and traditional software development lifecycle. We can consider this is a two-way methodology. Divide by phase, divide by activities. Understand? If you don't understand, just raise your hand. I can explain information. Okay. So again, IUP is the first model using iteration. Allow us to implement iteration in information system development.
Can you explain more inception, elaboration, construction, and transition?
Do you want me to explain in Vietnamese or English? English or Vietnamese? Depend on me, right? Okay, so I will select English. Firstly, you have to map, because IUP was built based on SSIDM and software development lifecycle, traditional SDLC. So, in the inception phase, inception is an abstract definition. It's different from analysis phase or feasibility phase in SSIDM. In SSIDM, if we are saying about feasibility, that means we spend 100% or 90% of our effort and time in analysis. If we are saying about feasibility, we are spend 100% in feasibility analysis. Understand? However, in IUP, when we say about inception, it's not only about analyze requirement. It's including all of these 7 activities, but focus mostly in business modeling and requirements. Or you can say that we spend around 60% or 70% in user requirement analysis and in modeling the business area we're working on. You see here? Yes. And elaboration. In elaboration, you can see that most of our effort and time and resource will focus on requirement analysis and design. This is about the structural design, database design, and implementation. So when we are saying about elaboration in IUP, we understand that we spend most of our effort, maybe 60% or 70%, for 3 main activities, including business modeling, requirement analysis, and implementation. In construction, don't misunderstand it here. In construction, many people think that construction is the same as implementation, or is the same as coding. Not like that. In construction, yes, we spend most of our effort and time and resource in implementation, but only around 50 or 60% on implementation. 40% remaining we spend for CCM. CCM does mean configuration and change management and analysis and design. We are saying a little bit about CCM. Have you ever heard about CCM? In summary, the user requirements never fixed, never stable. User requirements always change. So how can we manage on off the change request? For example, we have 5 iterations. And in each iteration, we have around 7 activities, right? And in the iteration number 2, customer have a change request on the activity of analysis. In the iteration number 3, customer have 100 change requests in business modeling. How can we manage all of that? About firstly, if customer submit a change request, do we accept it or not? If we accept it, what should we do? We have to consider about the effect of that change request to the whole system, directly and indirectly. And if we accept that change request, how can we store it? For what? For later use. In the future, if there is any defect, and that defect relates to a change request, how can we track it back? And the second option, if we reject a change request, do we keep the record about that change request? Yes, we do. Because sometimes customer will ask us, why don't you have this function? I asked you before. And you have to track it back to see why did you reject it. Or you ship it to another iteration. That is a summary about configuration and change management. And configuration is also related to the deployment environment. We know that we have at least 2 environments. The developing environment, right, on the machine of the developer, and deployment environment. In some cases, we have deployment environment to work parallelly with the legacy system which is running. How can we manage? That is about CCM. So you see that in construction, you can see that most of our effort spent on implementation of coding, but we also spend on CCM here. So never make mistake or misunderstanding in construction, meaning implementation or meaning coding. That is not enough. And transition. Transition, in some people we misunderstand transition have the same meaning as deployment. But it's not like that. You can see here, in transition we still spend a very little effort on analysis and modeling, 5-10%. However, we spend more of our effort on CCM. And you can see that CCM, the effort spent more for CCM from earlier construction to the end of transition. And again here, we also spend more effort on project management. And CCM in transition means how can we deploy the building system in a working environment. Understand? Everyone? Okay. Any question? Do you understand?
Yes.
Okay. And next is about the SDM life cycle. The SDM life cycle is differentiated from software development life cycle. Software development life cycle has a general meaning, but it's saying about traditional methodology. For the SDM life cycle, it stands for Dynamic System Development Method. And as you can see here, in the SDM, there are four main phases. The first phase is the same, feasibility study. And in this, we have another activity called business study. Business study is the main task for business analysis. Why do we need business study? As I said before in the previous class, we are IT guys, right? We understand everything in IT industry. But the project we are working on is not about IT. You can work for a healthcare project, for a financial project, for a construction project, for an education project. They are different industries. And if you don't understand about the industry, how can we implement the system, right? So that's why we need to study about the business we are working on. Study fully enough for understanding only. Don't be a master in that study. That is the job of business analyst. And in the second phase, we have something called functional model. Functional model is a phase including four main activities, including firstly identify functional prototype. We have to differentiate between functional and non-functional requirements. Every user requirement has two different kinds. The first one is functional requirement. Functional requirement is about a function we can see it run on the user interface. And non-functional requirement relate to things you cannot see. For example, about the security or about the performance of the system. For example, customers say that I want my system can manage student record, allow us to add new student, edit student record, or delete a student record. They are functional requirements. Because you can see, create new record, edit record, and delete record on the user interface. But when customers say that, I want my system to have two layers of security in the network, and it has to allow 5,000 to access the system at the same time. That is non-functional requirement because you cannot see, cannot interfere on the user interface. Understand? And in many projects, in many different information systems, non-functional requirements have a big impact to the whole system. And in most cases, non-functional requirement will have the impact on the whole system. So don't never underestimate the non-functional requirement. In some cases, it's much more important than functional requirement. So, come back to functional model. Firstly, we have to identify functional prototype. Functional prototype is a prototype that represents the main function of the system. Do you know what is prototype? No? Have you learned the ID course? Interaction design course? No? It's training. You are in DFM. Sorry, yes, DFM. You have to learn ID before. In ID, you will know about there are two main prototypes: the high fidelity prototype and low fidelity prototype. Remember? Read the book again. So we come back. Identify functional prototype. That means we need to build a prototype with major function of that system. Get it? And after we identify, we have a plan and agree on that plan to build the prototype. And then we create that prototype and then we build again until the prototype match to our requirements. And next we have the design build. In functional model, you can see that our main task is about prototyping. In design build, our main task is how to transform the prototype into real system. And in this case, we have two different kinds of prototype. One is throwaway prototype. That means if we're using a throwaway prototype in design build, we don't care about it, just build a new system. Or we use a development prototype. That means in design build, we can reuse the prototype we developed in functional model and transform it into the real system. And lastly, we have implementation. Implementation again, including 4 activities: training user, how to use our system, implement it, review business aspect, and user approval and guidelines. And you can see in the SDM, it's covered from the analysis, from the feasibility study to the implementation without testing. And one of the strong points of the SDM is that there is a connection between these files. That means at any time, anywhere, you can go back to any phase. For example, here at the review design prototype, and you find out there are some problems. You can go next or go back to functional model. In functional model, you can no way to go back to feasibility study. However, when you are at the implementation, you can go back to functional model or go back to design build or keep going to feasibility study. Again, do you understand?
I just misunderstand about functional prototype because I don't know before.
In order to explain about a prototype, you may need to learn about ID course. In summary, prototype we have 4 different kinds of prototype. Remember, one is throwaway prototype, and one is developing prototype. Throwaway prototype just means you build it and after it's finished, throw it away. Don't use it anymore. You just reuse the knowledge to build a new system. And development prototype, that means after building that prototype, you spend a lot of time and resource and effort in that prototype. You don't want to throw it away. So try to transform it from prototype into the real system.
Could you give some example about functional prototype? I don't know the output, the output of this phase.
I will show you a prototype, but I have to get the coursework from my course to show you. But after the class or when we are doing exercise, okay?
Yes.
And prototype again, we have two types based on the uh, usability of prototype. We call the high fidelity prototype and low fidelity prototype. Okay, we will show you later. Any question else? Okay, go next. So, what do we need from a system development methodology? You can see that there are 6 steps here, but actually just remember. For a system development methodology, first one, we need a generic framework. A generic framework does mean a framework can be applied for any information system. We don't need specific steps to implement a system. We need a generic framework because an information system never stable, never fixed. It's always changed. That's why we need a flexible and generic framework so that we can change it anytime we want. And after we have the framework, we need to identify the necessary step or mandatory step. The step must be done to complete the system. And after that, we might need to identify the optional step. That means if we implement those steps, we can add value to our system. But if we don't, nothing changes. It doesn't make any big impact on the system. And after that, after we have the step, we have to identify tools and techniques needed for each step. For example, in analysis, what tool do we need? Microsoft Excel, Microsoft PowerPoint, and technique, we may have interview, questionnaire, observation, anything you want to analyze. What tool do we need in implementation? Maybe a Visual Studio, maybe a programming language, anything, right? There are tools and techniques. And lastly, must be the end deliverables. That means we have to identify what are the deliverables of each iteration or each activity. For example, after doing analysis, what are the deliverables of analysis phase? User requirement list. The documentation of the report of the user analysis. What are the deliverables of the testing phase?
Test case, test results.
Test result, testing case, right? Testing report. They are deliverables. And remember, in the methodologies, the output of one phase can become the input of another phase. And so how can we know? That is a generic framework. A generic framework mostly will include two sides. The first side is about technical model, and the second side is about managerial model. For technical model, in summary, that is about modeling views like data model, process model, behavioral model. Understand? Can you see it? This is a generic framework. And a generic framework including two sides. technical model, and managerial model. Technical models, that means modeling views. Modeling views including data model. What is data model? Can you give me an example of data model? You know what? Most of you here was used to be uptake student. You don't know what is data model. What is that? Have you ever heard about ER diagram? Entity relationship diagram. That is a kind of data model. Class diagram. Okay? Data model. Process model. And behavioral model. What are those? Have you heard about sequence diagram, behavior diagram, state machine? Sequence diagram is a kind of process model, and state machine is a kind of behavioral model because it's dynamic. It's dynamic because state machine showing that how system changes over the time, and sequence model illustrate how systems react to a trigger to an event. You don't know about these models, do you? Oh, it's strange. Have you ever heard about these models, about these diagrams? Yes or no? Yes, but for what? Or never heard? I believe you used to learn about it, but you forget. Because one of the preconditions of this course, you have to learn about system building or something like that. And in system building, you have to learn about this model already. Right? So you have to review about this model in order to understand and a better understanding about this one. Okay? So in summary, technical model is about modeling views. And modeling views including three main views: data model, process model, and dynamic model. In some cases, it will consist of case or IPSC package. Case package like use case can be used in some methodologies like using UML. You can turn from a use case to a test case or to code, which can generate code from use case. From case package. And the other side of generic model is managerial model. Managerial models, this is model about how to manage the system. So it provides a framework with which development will take place. Or in managerial models, it defines state, and tasks to be undertaken. So again, managerial model is nothing to do with technical issue. That is about management skill. You have to define who will do what, and when, in how long, and what are the results you might need to implement that task. So you can say, in a generic framework, it's including two factors. One is about technical, and one is about management skill. And in management skill, that is also including how developer interact with the user, or how developer will gather requirements from the user. This is a very different point from a traditional SDLC. So again, you can see that in managerial model, it focuses on when they will be undertaken, or when this task will be implemented, which are critical, which are not, how they should be managed, how development and team work together, and what are the end deliverables will be. So you can see here, the work here is not only about technician, like before, like 1960. In 1960, everything in an information system development project is all about technical issue. If there is any problem, they will try to resolve it by using technical skill. For 1980, it's different. The works including two halves. One half for technical, one half for management. Okay? So where we got to today, and there are many development techniques have been changed over 15 years, actually 25 years. The approach to system development still continue to evolve. And we have some development approach for web-based projects are poor. Many systems developed using system building tools. However, there is some agreement. You have some kind of framework within which to structure your project. That means in 1990, people just need a framework. And that framework should have the function to help you to structure your project. They need something to structure the whole structure of the project. However, today developers have much more realistic view. You have the result, and you have the ingredients, and you have the user requirement. And your job is how to create a meal by using your result and your ingredients meet your client's flavor or meet user requirement. Understand? Now you don't cook on yourself. You have to cook based on your customer wonder. Understand? So here are some basic knowledge about framework. Any question before we go into the next section? No, okay. And next we will learn about some framework and method which used to popular in before. We have Prince. Prince actually is not a project development framework. It's a project management framework. The difference here is about development and management. How to manage a project. Any project, not only about IT industry. And SSIDM, as I said before, it used to be very popular in 1980s and even was used in early 1990s. And UML, this is a collection of best practice modeling techniques. However, it's not a framework or method. IUP, we just learned, and Asia method. Actually, Asia method is not a specific methodology. It's a family of many different methodologies. And however, Asia method was based on an approach. That approach is ARD, or Rapid Application Development. So what is SPRINT? SPRINT stands for Project in Controlled Environment. That means an environment that can control or manage a project. This is not a system development methodology. This is a project management framework. And it's not just for IT-based project. This is way back 1999. And actually, now PRINCE become a standard for project management in the public sector. PRINCE 2 is the latest version. I will tell you a little bit summary about PRINCE 2. PRINCE 2, like I know that when you attend a course, you have to pay a lot of money to attend PRINCE 2 course. Because this is a project management framework. So after you graduate from that course, you will have a certificate saying that you graduate from a PRINCE 2 course. What does that mean? That means you can become a project manager for any project. Because PRINCE 2 is about management, not only IT industry. And in many public sector or many public projects in UK, PRINCE 2 is an adaptive methodology. And most people there, if they want to become a project manager, they have to have the PRINCE 2 certificate. Just like in our IT industry, we have a specific certificate called BNB. Have you ever heard about that? Project Management Professional. So in some countries, in Vietnam and in the US, if you want to be promoted to become a project manager, you must have BNB certificate. And as I remember, in order to get a BNB certificate, you have to pay for the examination fee. And that fee for 10 years ago was 10 million Vietnam dollars. And for PRINCE 2, maybe 5 times or 6 times expensive than BNB. However, the payoff is very good. It's work for that. Because for project managers who have a PRINCE 2 certificate in UK, they have very high salary. As I know, the average salary for a project manager have PRINCE 2 certificates is around £90,000 per year. 90,000 UK pounds, yes. And this is a PRINCE 2 framework. PRINCE 2 framework divided into 4 layers. The first layer is corporate or program management. And the basement layer is about planning. And planning will be the phase to create impact on these 4 phases, including from starting up the project until closing the project. That means planning will create impact on these phases. And you can see all of these phases will have the connection or linking to directing a project. And in controlling phase, you have the managing product delivery. Managing product delivery is a specific activities in controlling a state. Because, as we studied before, after 8 phases or after 8 activities, we must have a deliverable. And this focuses on manage the product delivery. In summary, this is the framework of PRINCE 2. So is it worth worrying about? According to IT job, what ranked 62 this quarter. This maybe a couple of years ago, an average salary £50,000 per year. Well, this is a number for
5-6 years before. The first time you may get up to 90,000 pounds. 90,000 pounds is around 2,700,000,000 Vietnam per year. Or you can say that each month you will pay around 200 million Vietnam or 10,000 US dollars. Is it work? However, in order to get into a Prince education, the cost is quite expensive. SSADM adopted for public sector in the UK used by government in 1983, and it's originally aimed at traditional waterfall development life cycle. However, SSADM gained a reputation for being bureaucratic, unwieldy, hard to use, unproductive. In 1990s, there was different version and make it more attractive to developer. It become more attractive to developer because of three main reasons. First one, we have a cookbook approach. What is cookbook approach? That means a formula to build a specific information system. For example, if you want to cook one meal and you don't know how to cook it, there is a cookbook, and you just follow the cookbook, you can cook the meal, right? The same in information system. You don't know how to build that information system, there was a cookbook approach for you. Just follow it and you can build that system. So that's why it's become an attractive framework for most developers at that time. And it also has a red version and also has an object-oriented version. However, SSDM become old fashioned nowadays. And SSDM style has a number of steps. Each step might have a number of sub-steps, and each sub-step has one or more deliverables. These are the activities in requirement analysis of SSADM. You can learn that from. So is it work to learn about SSADM? It's running at 778. They don't have the statistic of average salary for people who have SSADM certificate. YML is Unified Modeling Language. It's not a methodology. It's a set of specifications and design notation. For example, here are the documentation, including model and diagram using UML. We have like activity diagram, deployment diagram, model diagram, class diagram, use case, sequence, corporation diagram, and the set. A set of combination of these model or diagram, we call this a unified modeling language. Or we communicate with the computer via diagrams. Is it work? Yes, it stands up for object-oriented modeling. If you have learned object, you must learn object-oriented, right? And if you learn object-oriented, you must know about UML. Have you ever written any use case model?
Yes.
Yeah? Okay. However, UML has big criticism because it's too complex. It's ranked 93rd. Next is IUP. IUP is a use case driven architecture-centric, iterative, and incremental. And IUP is the most used approach for nowadays. And in some companies who get they get the certificate of I don't remember. They follow a process. I suddenly forget that process. Cannot remember. However, in order to get that certificate, they have to prove that they follow IUP exactly. They follow the use case, they have the iterative and incremental process. Use case waiver, because everything in IUP will surround use case. From use case, you have test case, and the developer will develop the whole system based on use case. So you can see that most of phase in software development lifecycle surround the use case. And iterative and incremental. Do you understand why iterative and incremental? Iterative and incremental can be considered like a new approach for nowadays. Iterative and incremental can represent by this one. That means iterative, a set of activities will repeat. You can see repeat again and again and again and again and again. And incremental, that means after each repetition, it becomes bigger and bigger and bigger, like this one. So that's why we call this an iterative and incremental approach. In summary, iterative and incremental approach divides the whole project into small phases. And in each small phase, every step will be repeated again and again and again during different iterations, just like IUP. However, after each iteration, the scope of implementation will be expanded. This one. This thing you can do at home. Agile method. And again, Agile methodologies, family of methodologies is not a single approach. And this is original concept of ARD, or Rapid Application Development. Agile Manifesto, including individual and interactions. Agile Manifesto, like the statement of Agile methodologies. According to Agile methodologies, you have to remember these 4 points. First one, individuals and interaction have higher priority than process and tools. What does this mean? We don't need to follow exactly the process. We don't need to use exactly the tool recommended by the approach. We pay more attention and pay higher attention, higher priority for individuals and interaction. That means we spend our effort and time on people and how people can interact together. In our words, we can say that Agile Manifesto focus on how developer and customer and team member interact together. Because after the Gatsby conference in 1990s, people saying that in order to create a successful information system, 50% of that successful comes from the customer. So, developers have to improve, increase the interaction with the customer. So again, Agile methodology is focused on individual and interaction. You don't need to follow the process and do it separately. And secondly, working software is better than comprehension documentation. This is different from SSADM, right? Remember, SSADM focus span 2 phases for documentation. However, nowadays, people want a working software, then a comprehensive documentation. They don't need too much documentation for a project. They need a software that works. Thirdly, customer collaboration is much more important than contract negotiation. For example, in the contract, it doesn't mention about one function. However, if we have that function, we can add value to the customer business. So, as a developer, we will be ready to do it. To help customer to give more adding value for our customer. Don't just follow the contract. And next thing, responding to change over following a plan. Many developers say that I don't have time to reply for customer requests. I have a lot of tasks to do and behind the schedule. But remember, customer is the end user. Customer is the one who pays for us. So, try to respond to the change request. Don't just stick to the plan. Understand? So, again, Asia Manifesto including 4 main points. Individuals, interaction, working software, customer collaboration, and responding to change. Understand? Any question? If you don't have any question, then we can take a break in 5 minutes so that you can refresh your mind. Okay?
And forget everything. And forget.
Thôi đâu đó đừng sao cô bây giờ